thank you for joining us this morning. It's World Green Building Week this week, and this is just one of the sessions that we're running all through the week across the globe, and it's about triage for an ailing planet. So Sophie will take over and discuss that in a couple of minutes. If you've got any questions, you should be able to see a question and answer box at the bottom of the screen. If you could just ask any questions throughout the presentation, and what we'll do towards the end of the session, we'll pick those up, and we're hoping this will last about 40-45 minutes, and then we'll approach any of your questions then. If we don't get time to answer all the questions, what we'll do, as long as you have not asked a question anonymously, we can follow that up with you via email and make sure that we get your answer to you. So I think without further ado, I'll hand over to Gordon.
Thank you. Good morning, everybody. I'm Gordon Reid. I'm one of the partners in Newcastle office. I'm going to set the scene for the presentation today, give you an idea of the things we're going to talk about, and also introduce our key speaker. So the title is Triage for an Ailing Planet. Obviously, we're talking about climate change. I'll explain a little bit more what we're going to talk about shortly. So next slide, please. First of all, for people who may not know too much about our business, we started in Newcastle in 1976. We've now got 25 offices globally, and we've delivered work in more than 50 countries around the world. One of the things that we're very proud of is we're the first consultancy to be accredited with One Planet Living status, and we've just achieved carbon neutral status in our Australian offices, and we are actively seeking that across all of our offices, and look out for some announcements very shortly on that one. Next slide, please. So here we have areas where we work. The dark blue are areas where we have an office, and the paler blue are locations where we don't have an office, but we've currently got projects on the go. So quite a wide coverage, and we are hosting this seminar across all of our offices across the world this week. Next slide, please. So what do? We offer a range of services that we class as core services, and you would probably think about MEP, civil structural, and sustainability as our core services, but we can offer all of the services you'd expect of a consultancy like us, with the specialist services associated with transportation, health and wellbeing, geotechnical, etc. You can see all of these services there on the screen. Next slide, please. And we work across all the sectors that you might expect. So we've got a good range of skills, a good range of knowledge, and we bring those together. Certainly when we're talking about sustainability, we can learn a lot across all of these sectors. Next slide, please. So today's talk is about climate emergency. Many governments across the world have declared a status of climate emergency. And how are we faring against that, really? That's the main thrust of the talk today, but more importantly, what can we do to address that situation? Most of you will be familiar with the Paris Agreement, where there was a target of 1.5 degrees of temperature increase compared to pre-industrial levels, with an absolute upper limit of 2 degrees. Every piece of evidence that we can find suggests that we're on a pathway to a 3-degree rise, which is obviously going to have some very profound effects on our environment and for all of us who live within it. Next slide, please. So the sort of thing we've all seen on the news, or we may have experienced personally. We've seen bushfires in Australia, in America, in Southern Europe. And if we're thinking more locally, obviously we had flooding in this area as recently as February. We really need to act now if we are going to make sure that we don't see the more profound effects of the potential 3-degree rise. Obviously, the main objective is to try and limit that rise so we don't get to 3 degrees. So talking about some of the drivers for change, also already mentioned the Paris Agreement and the climate emergency that has been declared. The UK government in May 2019 announced a formal climate emergency. The Scottish government did likewise. Interestingly, very shortly after that, the Climate Change Act that was first drafted in 2008 was revised to set a target for greenhouse gas emissions to be net zero by 2050. Again, about a month later, the Committee for Climate Change actually announced that we were already failing to achieve some of the targets that were set in the 2008 version of the Climate Change Act. So whilst it was very encouraging that it was revised in 2019, we're not doing very well on our previous promises So we do have a serious issue to contend with. Next slide, please. So in terms of climate change, local authorities across the UK have actually made a pledge and made a commitment to do something about it. Again, we're in Newcastle today. Newcastle have said by 2030 they're going to achieve net zero status. Other public bodies in Newcastle, such as the university have said that they will achieve climate neutral, net zero carbon status by 2040, and so the Health Trust. So it's encouraging that there are drivers coming from at a political level, also at a regional, publicly funded level. So that's encouraging to see. Next slide, please. Other drivers that we can see that we've experienced as Cundall, we're seeing investors now starting to insist upon the net zero targets and strict improvements to release funding. Developers are signing up to net zero carbon commitments. They can obviously realise that it increases the value of their asset if they can establish its credentials. And we're also seeing a lot of pressure from the market, from occupiers and clients who want to see net zero carbon being achieved based on science-based targets. So it's good to see that we've got these drivers coming from across our industry. It's more important about how do we actually respond to that, and how can we apply expert knowledge to make significant improvements. So what I'm going to do now, I'm going to hand across to my colleague Sophie Simpson. Sophie's an expert in climate change. She'll take you through the rest of the presentation. And as you can see, we've entitled the presentation Climate Triage. What we're going to do is work out how we can prioritise actions and what those actions need to be. So I'll hand over to Sophie now, who will take you through the remainder of the presentation.
Thank you, Gordon, for that introduction, and thank you everyone for joining us to discuss this today. So in terms of the operation of buildings, then we're aware that this is responsible for 28% of emissions across the globe, but this increases to near on 40% if we also include the emissions associated with the materials and construction of buildings. So it's worth noting at this point that this means the embodied carbon associated with construction projects currently represents over a quarter of emissions associated with the built environment. But if you're not already looking to understand this, then it's likely you will need to soon. Therefore, it's imperative that we start considering and developing scalable solutions that will help us to address this challenge going forward. In recognition of the role of the built environment has to play in tackling climate change, we are now starting to see consensus among the industry in terms of the level of action that needs to be taken. So the World Green Building Council, then they set out their roadmap outlining that by 2030, all new buildings must be net zero carbon in operation. And then by 2050, we're looking to see all new buildings whole life zero carbon and all existing buildings zero carbon in operation. So alongside this, the UKGBC have developed their framework, and this has essentially got two threads with their own associated definitions and principles. So the first one here shown in blue is the kind of strategy for net zero construction, and the second one in green is in relation to net zero operation. So for the construction of new buildings, there's an expectation that these will be designed to also achieve zero carbon in operation. So that's what the Ds represents there relative to operational energy use and increasing renewable energy supply. But ultimately what we're looking at is first reducing our construction impacts, optimising operational performance, and subsequent to this, increasing our renewable energy supply. After all of this, what we can then do is consider our carbon balance and review opportunities to offset this. However, I want to iterate that one, this is a whole different presentation, which we're happy to elaborate on another occasion, but ultimately, we're viewing this as a last resort or to consider it as a short-term fix until we can move forward. This graphic on this slide is taken from the LETI design guidance. So if you haven't already seen this, I strongly recommend reviewing it. It's a really useful document, and our colleague Jen from our London sustainability team was involved with its development. So what it essentially uses is a top-down and bottom-up modelling methodology, and that's been used to determine valid performance targets that are considered feasible to achieve based on market available technologies. But it's worth noting that the findings are essentially consistent with those of the other kind of industry players such as the UKGBC, REBA and RICS, which I'll touch on again later in the presentation. So the purpose of this figure is to demonstrate that to achieve net zero status, the level of energy demand has to match the available energy generation sources. But currently our demand far outweighs this. So there's a limit also in terms of how much renewable energy can be generated within the UK. So this essentially means that there's kind of a balance and actions to be taken on both sides. So the priority is to reduce demand requirements, but also simultaneously increasing the renewable energy generation until we can achieve a balance. And this slide is basically trying to reiterate some of these points. So we have to look at all the different sectors, so industry, retail, office and residential, and understanding how the demand reductions can be achieved in each of these industries and balance that off against the increase in renewable generation. But we've got a lot to do here, and a key part of that is changing our mindset. So whilst we have been taking action to date, it's not been taken as far enough. So we really need to kind of review what we are doing going forward in order to get different results. So intermittency, then that's one of the concerns in relation to energy generation. So we're kind of needing to look at what are the implications associated with this, and also what are the implications of introducing new loads to the electrical infrastructure, such as the introduction of electric vehicles. So whilst this graph gives us a kind of good, almost two-dimensional kind of representation of it, then we also have to think, how do we do that relative to matching the time of energy supply and generation? Can we move towards smart technology and incorporate the effect of this dynamic? So if we kind of start to focus back in on operational energy, then Hywel Davies, the technical director at CIBSE, said delivering zero carbon buildings is a huge challenge. Letty has taken a major step to help the industry work out how this is to be done. So we're going to use their example here. What they recommend for offices in particular, they've got different targets if you're looking at residential or schools, for example. But for offices, we've got an energy use intensity of 55 kilowatt hours per metre squared over the year. So what this graph is highlighting is an assortment of measures that can be implemented in order to bring a building from its maybe current benchmark performance to a low energy design solution in alignment with net zero carbon operation. Each step represents a recommendation, and this is based on products or materials, as I said, that are currently available. But it also requires quite a detailed understanding of how the individual building is intended to operate. And this is where there's no kind of silver bullet that kind of solves this situation for everybody. You have to look at the individual needs and requirements of those single assets to kind of identify the best strategy and optimize its performance for the function that it serves. But as I mentioned earlier, materials and construction represent over a quarter of the emissions associated with the built environment. So we've now got a good understanding of how we can reduce operational emissions. It's a case of putting that into practice. But what this means is that as buildings perform better during their occupied life, the whole life emissions will start to reduce. And this is represented by the decrease in size of these circles going forward in time. Fortunately, we've got the skills and the tools available to help us understand what the implications are in relation to embodied carbon, where this starts to become more significant as we go forward. And what we're having to try and understand are what are the implications of first the upfront emissions associated with the construction, but also what are the ongoing maintenance, the repair and the replacement works and implications associated with those. And so what this means is we need to start understanding how the material choices, the construction techniques and the kind of decisions that we make early in the design process, for example, affect and impact the environment. So just as an example, we are looking at what are we doing in terms of the extraction of raw materials? What is the energy and carbon associated with processing materials? How are these transported to be further processed into products? And then how are these subsequently transported to site, for example? So we're starting to get quite a complicated process, but as I say, we do have kind of tools to help us understand that and quantify that. In addition to that, where that's just kind of looking at our kind of upfront kind of emissions, upstream emissions, we're also needing to start considering what happens at the end of life. So are we specifying recycled goods that reduce the kind of the impact of those materials, but then can they subsequently be reused and recycled at the end of the building's life? And are we also designing for disassembly? So there's a lot more to consider over the whole life of the building. And it's no small feat starting to calculate this embodied carbon targets. So this graph here, it represents a breakdown of associated upfront and whole life embodied carbon targets for 46 example studies. So at the moment, the average kind of performance for this is 1,030 kilograms of CO2 emissions equivalent per metre squared. Which might not mean very much unless we understand the context relative to our zero carbon targets and the scale of improvement that's necessary. So what we then have, for example, is the Greater London Authority. Now, they've done a lot of work in trying to progress kind of planning requirements in a movement towards zero carbon status, and they've set this benchmark figure of 900, so there's a degree of improvement that we need to be considering here. But then if we go on to consider the LETI guidance, they've set progressive improvement targets to get us towards this whole life zero carbon by 2050. So for the kind of immediate upcoming target of 2030, they're suggesting 600 kilograms of CO2 per metre squared. But by 2050, they're seeking to have a target of 350. So you're looking at almost a third of what our current average is. And this slide here, what we're trying to do is just summarise a range of the targets and assessment metrics that we are starting to see become more commonplace on the projects we work on. So that's in relation to kind of the REBA guidance, the Greater London Authority, LETI, or the UK GBC. And I believe that the presentation will be made available online if you're wanting to refer to these slides in detail later on. But it's worth noting that while planning has a role to play, it's not necessarily the key driver behind kind of these targets. And we're getting a lot of attention we're seeing in this area is kind of coming from the kind of corporate level or organisation level, or people who want to demonstrate the environmental credentials of their work. So in order to achieve net zero carbon buildings, essentially every aspect of energy consumption must be considered and minimised. But the issue being here is, what is the minimum? So the best action that we can take is therefore to look at all the energy flows in a building and identify how these can be minimised without interrupting business continuity, and then looking to generate as much renewable energy on site, thereby creating a zero carbon enabled building. The point at which the building reaches zero carbon in operation will therefore be dependent on the rate of increase in the renewable energy content of the grid as well. So here we've got our operational, our design optimization. We're also then looking to eliminate fossil fuels on site, and when we've got our renewable energy generation, we're also taking into account upfront embodied carbon, considering whole life carbon in conjunction with whole life costing. But another key important factor is that public disclosure of performance, for example, using the RAP database. And this brings us to our triage for the built environment. We recognise that we are currently in a climate emergency, but much of the effort to date has been focused on new buildings. So we need to be thinking, what are we doing about our existing building stock? And from what we've considered, I think we can understand that there is a need to design buildings that last. And we've already done this to a certain extent with, I think the statistics like an estimated 80% of the built environment in 2050 has already been built to date. And as much as 40% of that was constructed pre-1985, before the Part L regulations were introduced. So from the perspective of a climate emergency, this essentially represents our walking wounded. And what we need to understand is, how bad is it? Which ones, for example, require emergency attention if we are ever going to limit our global warming to 1.5 degrees Celsius? Which ones are the ones that we can then address through a care strategy implemented over time? But then also, which buildings are essentially at the end of their life where no amount of effort is going to get them to zero carbon? So where to start? What we've identified in terms of the work that we've been doing today is that there are essentially 3 key levels at which we're being asked to assess zero carbon strategies. So we have this at a corporate level, where we're looking at emissions across the whole organisation over a reporting year. And this is taken into account day-to-day operations. So for example, it's including everything from how staff get to work to the materials that are being specified and used and extracted and so on. And this has been assessed using, for example, the science-based targets methodology, which can be used to demonstrate an organisation's efforts to operate within the limits of a 1.5 degrees Celsius temperature increase. At the other end of the scale is the individual asset. here we are considering the operational performance of the building as well as the embodied carbon that's maybe associated with its either upfront construction or ongoing maintenance and so on. Whilst existing buildings may not have the upfront emissions from construction, we do still want to consider the emissions associated with the maintenance, but also any replacement, repair and refurbishment works that might take place over its lifetime. And then, as I mentioned before, we also have the end of life implications. So can we disassemble kind of parts and components? Can the materials be reused and recycled? What are the values associated with this? So I've already touched on a number of the frameworks, but I think I'll go into more detail later on in terms of how this is affected with the RICS whole life cost carbon methodology. And between these two levels, we then have the portfolio level. And this is where we're looking to collate information relating to all building assets owned or operated by an organisation. So much of the effort to date has focused on our scope 1 and 2 emissions, so from any fuels combusted on site or electricity, for example. But we need to start taking into account what are our scope 3 emissions and the level of impact. I'll go into more detail on this later, but it's worth noting that where these haven't been considered to date, they do have the potential to be quite substantial, representing an estimated, been estimated to represent as much as 80 to 97% of some of an organisation's total emissions. So they are quite significant on occasion. Within this is where we're looking at, for example, the procurement of products, materials, but it's also in relation to kind of the services that are being provided. So this is really important in terms of kind of understanding supplier engagement going forward. And so one of the first steps in order to kind of get a better understanding of this is to first establish the boundary around what is encompassed within this assessment. So, for example, if we're looking at an organisation level, then that's all your buildings, but as I said, you're maybe looking at the people, but kind of their activities and behaviours, but also the services that you're procuring. For example, a council level, then they might decide to kind of break up how they assess the different areas. So they might have targets relative to transport, but they might then have separate targets and strategies relative to just their building stock. And as I say, it's very important to kind of start developing on the relationship with your suppliers and engaging with them in order to understand what are the implications of their kind of strategy and how their carbon emissions and how that impacts on yours. So once we've got this clear boundary established and understood, and this might be relative to kind of financial control or operational control as well, then what we can then start to do is kind of quantify it and understand what the level of impact is. So that then gives us an indication of the scale of the problem. So what are our total emissions calculated? And from this, we start to get an understanding of what the key contributors are. Now, this is really important as it helps us understand where we can have the biggest impact in terms of undertaking remedial action. And what's really important to note here is it's about understanding the whole carbon footprint and what we can do to reduce this. We don't want to just focus on a toe print, and because that's where we start to have misdirection of focus, and we're not necessarily kind of getting the level of reductions that are ultimately necessary for our ailing planet. And a good example of this that somebody provided the other day was like if you're considering the debate about whether a hand dryer or hand towel is better for the environment, but you're standing in an airport at the time, then you've been misdirected, you're focusing on the wrong efforts. So again, calculating our carbon footprint, that's the first priority, and from there we can understand what efforts we can implement to reduce the carbon footprint. Then and only then do we want to look at our carbon offsets. But as I said, like that is ultimately, we want that to be considered as a short-term solution, something that we then have in place from the outset, but then go on to reduce over time so that you're less dependent on this. And this is kind of this is in terms of kind of providing some resilience and protection where we don't know how the costs of carbon offsets are going to change over time. And what they represent essentially is a fee that's paid for reducing carbon emissions somewhere else or kind of in contribution to that. So it might be a cost contribution towards renewable energy projects such as wind farms or biomass energy, or it might be a kind of fee paid towards energy efficiency projects. So what are we including when we consider our scope 1, 2 and 3 emissions? So you may be familiar with this already, but just as an overview, then our scope 1 emissions are our direct emissions. So those are those that are from sources owned or controlled by essentially the reporting company. So this is essentially any fuel that's combusted on site, so gas boilers, for example. But it's also worth noting that this also includes any emissions relative to refrigerant emissions associated with your air conditioning systems. If we move on to our scope 2 emissions, then this represents indirect emissions, which are relating to purchased electricity. But again, this also is any type of purchased energy sources, so can include purchased heating, cooling, or steam. Once we start to incorporate our scope 3 emissions, you can see that it suddenly seems to get a lot more complicated. So what I've taken here are the different categories defined for scope 3 based on the Greenhouse Gas Protocol methodology. And so you have 15 altogether, 8 of which represent upstream emissions. And so those are ones that you can influence emissions based on your choice or selection of actions. And then you have your 7 downstream emissions, which represent emissions associated with services or products that you offer. What's important to note is that nobody wants to double count. The whole system doesn't allow double counting of scope 1 and 2 emissions within that 1 and 2 categories. However, when we come to our scope 3 emissions, it's a bit more relaxed. And the tension behind this is that we essentially want everybody who has an ability to influence emissions to have some degree of responsibility associated with that. So for example, if there is an organisation which leases out a building, then you have the electricity consumed by the tenants, that represents tenant scope 2 emissions. But that's tenant scope 1 emissions are the that tenant scope 2 emissions for the electricity are the scope 1 emissions of the power generator. And so they will never be anybody else's 1 or 2 scope emissions. But for the building owner, then they essentially become scope 3 emissions on the basis that that is a service, the building is a service that they offer to their tenant. And that's because everybody in those 3 roles has an opportunity to reduce the emissions, whether it's through behaviour change of the tenant, whether it's the building owner optimising the performance of the building, or it's the energy generator improving the efficiency of or increasing their renewable contribution. But as I say, this is kind of covering any type of assessment, and what we want to do is kind of focus how can we link this to the built environment. So there's a degree of simplification that we can start to implement. So it's not as terrifying as it initially looks when you see the 15 different categories. But what makes this approach really interesting and going to have a significant impact going forward is, for example, if you look at the downstream emissions, then anybody with a responsibility for a building portfolio, then what they're going to have to consider is the use of any sold products, the end of life treatment of those sold products, and the kind of leased assets. So in terms of sold products, then what this essentially means is that for portfolio managers, if they have any poor performing stock, they can't just dump this and then not have a consequence. They have essentially got responsibility for the operational performance of those buildings. And so if they sell them on, then that the anticipated performance associated with those buildings is included within the scope 3 budget accounting. And again, the end of life treatment. So this then places a responsibility on building owners to ensure that they are bringing their building stock up to scratch. And this is where I think we're going to start seeing a lot more focus in terms of the value of buildings going forward in terms of their carbon performance. So this brings me to the RICS methodology, which is used for assessing the whole life carbon of buildings, which is the industry recognised standard for this type of assessment. And our colleague Chan was integral to the development of the methodology. And it's comprised of 17 phases, taking into account emissions across the whole life cycle. So you can start to see there's some synergy in relation to what we've been looking at for the Greenhouse Protocol's 15 scope 3 categories, in terms of we've got the extraction of the raw materials, transporting that to site, and the manufacturing emissions and so on, but also looking at the end of life treatment of that building. what we are trying to do at Cundall is align this scope 1, 2, 3 emissions as we've reviewed for the greenhouse gas protocol, and align that with the different categories of RICS methodology in order to help our clients understand how to kind of achieve benefits and improvement to their building stock going forward. And so this is where we're then kind of trying to understand and recognise the scale of the problem. And from this, we can start to recommend targets and set strategies in order to facilitate the realisation of these essentially. And we're seeing a greater use of a range of tools in order to facilitate this. So kind of coming back to the operational performance, then the Neighbours scheme in Australia has been delivered to great success. And where this is using much more detailed modelling and undertaken at design stages, but also following that through to performance in order to kind of determine whether that has been achieved in practice. And this is having a really substantial impact on the quality and effectiveness of the scheme in terms of delivering higher rental yields for properties which are neighbour rated. What we're starting to see is that this scheme, a kind of equivalent scheme, is being rolled out across the UK, and we're using design for performance, for example, to assess the operational performance of buildings. So here you can see with the kind of the triangle points, then the higher the energy performance associated with the building, the poorer the ultimate rating. And as I've touched on, part of the challenge is identifying where we can make that biggest impact. So this slide represents a really interesting project our colleague Duncan was involved with for Newcastle Council, which he can elaborate on in more detail at the end of the presentation if anyone's got questions. And essentially, this is reviewing the available data sources describing our building stock. So for example, whether this is from energy performance certificates or display energy certificate databases, and using this analysis to strategically consider building performance across the city. And this has facilitated the easy identification of essentially problem buildings, which in this instance I'm taking to mean buildings that are demonstrating a much higher energy consumption than is typical for a building of that type. So for example, in this instance, we can quickly extract information identifying those properties demonstrating F and G EPCs, and that are going to necessitate action to address pretty quickly. So through this identification, contributing factors can be identified and a strategy can be developed to reduce consumption. A great benefit of this approach is that it's using existing available data. Therefore, the assessment has been, we've been able to proceed with this assessment during lockdown. So this has enabled Newcastle Council to continue to demonstrate progress with regards to their efforts towards achieving emission reduction efforts, even where they're maybe not getting easy access on site. And so this kind of brings us from our understanding of our portfolio performance to what we need to do for individual assets once we've identified where action is necessary. So as I mentioned previously, then Cundall have developed their 7-step strategy, and what we're using is this to undertake a high-level review of building assets. So this allows us to do a quick identification of what areas we need to make progress and recommend strategies in relation to improving this. But the ultimate aim is to move from the kind of current performance level. So here, the blue bar is comprised of fossil fuel and electrical energy consumption, and ultimately moving towards a recommended energy use target. So as I mentioned earlier, for offices, then that's 55 kilowatt hours per metre squared energy use intensity target. And this is where we're using our detailed energy modelling and basing that on calibrated data based on real energy data. So using utility bills, for example. And what this does is it starts to reflect actual operational requirements as suits the needs of the occupant. So it's worth noting that this is distinct from modelling efforts for Part L, which are solely to test the performance, solely to test kind of compliance performance. So have the building fabric been designed to building standard requirements, but also to provide an easy comparison of buildings for like basis. But it does not represent how they will be used in practice. So the calibrated modelling, then that allows us to identify appropriate and effective carbon reduction efforts that suit the individual building and can be used to develop a route map to implement kind of carbon reductions towards this energy using target over the years. And and through considering this route map approach, then what we can do is develop a strategy, and this can be developed so that it takes account of existing maintenance, replacement and refurbishment schedules. So this allows us to identify opportunities to implement efforts that tie in with scheduled works, or for example the introduction of new leases, and thus minimises the level of disruption associated with the process whilst maximising the potential benefits. And so there are a number of quick wins and that we can see associated with this in order to kind of get that initial reduction down. So this is just a list here, but as I say, I won't go through this in detail because presentation you'll be able to kind of catch up on this online. But also what we've got here are kind of a summarised key considerations, which are quite the easy ones to kind of consider from the majority of projects. So optimising glazing areas, improving thermal performance and air tightness, making sure we have those openable windows, even if we have a mechanical ventilation strategy, because that allows us to kind of offset the dependency and use on that in months when it may not be necessary, and enable, but it also allows us to enable mixed mode ventilation strategy. Ultimately moving towards phasing out the use of fossil fuels. But then what can we do in terms of the day-to-day operations? So for example, can we relax the temperature set points to reduce energy consumption? Are there opportunities to reduce internal gains and thus the associated cooling penalty? And then if we implement all these improvements, can we reduce MEP sizes and the associated capital costs associated with those? Following on from that, maximising our on-site renewables so that that covers a greater proportion of the building's energy. So at Cundall, we offer a range of services, and this is growing vastly in interest in terms of what we can do to support a corporate strategy approach and reporting, but also what can we do to support our clients in terms of their portfolio of stock. And again, we offer our usual services in terms of our net zero carbon buildings. So we can design to passive house, or we can undertake those operational energy assessments, and this kind of design for performance, which is gaining a lot of interest at the moment. So ultimately, the cost of inaction is greater. Sorry, the cost of inaction is greater than not doing anything. So it doesn't have to be a complex process. This is something that can be incorporated within existing plans and strategies, and it will reap multiple benefits in terms of not only minimising the impact on the environment, but improving sustainability credentials, improving the quality and value of the building stock, but also optimising the resilience of that building stock relative to a changing climate. And so that brings us to the end of our presentation. If there's anybody that wants to go over questions, or if there's anything you want to hear more about the work that Duncan's been doing with Newcastle Council.
Thank you, Sophie. That was a lot of information, so thank you for going through all of that. We do have a couple of questions, but I think maybe we've got a little bit of time. If we can just ask Duncan to jump in with the work that they've been doing at Newcastle City Council. If anybody's got any more questions, ping them across, and then we'll cover them in a couple of minutes after Duncan's couple of slides.
Good morning. Hi, thank you for the opportunity just to chip in at the end here. So if the work we've done with Newcastle, I could see Adrian's on the call. We have taken the strategic information from the DEC and the EPC databases, but that came out of a conversation initially to hear what it was that Newcastle actually wanted to achieve. So if you jump to the next slide for me. So this was about understanding the client's priorities, because at the end of the day, that's the most important thing, is to actually hear what the client wants to do and help inform that process. So it was really about understanding what they wanted to do, and not only to achieve the carbon savings, but think about return on investment and where they might be able to generate the best benefits going forwards. Next slide, please. Some of the interesting things that came out of the discussion was that quite a large amount, a very high 80% proportion of the buildings were using standard infiltration, which is one of the aspects that that assessors use for EPCs, which was generating excessively conservative versions of the EPC ratings, and actually effectively driving the values of their stock downwards by driving potentially Ds and Es down to Fs and Gs. Next slide, please. So we went through a whole process of looking at a range of interventions and really just tried at that strategic level to see how those might apply and what they might generate for the client. Next slide, please. So it wasn't just about the cost, it was also about how quickly that firstly might be able to deliver the work, but also how it then might look in terms of actually the payback periods. So there were some elements of cost to the assessment as well. Next slide, please. So with some little bits of help from our friends at Faithful and Gould, who gave us a little bit of outline about cost per square metre for these sort of things, we were able to bring that into the assessment. Next slide. And overall, it then came down to helping the city to understand which of the buildings were the big hitters, as Sophie said. Which of the buildings, which are the highest priorities of the where they could start. So where we would start to look at doing the next stage of assessment. Next slide, please. As you've already seen, this is the summary table. Obviously, we've taken the addresses off for obvious reasons, but the idea was that we would be able to look at a number of options and understand what the benefits could be, both in terms of kilograms of CO2, and then next slide, please, the other options of looking at this payback period option and how that might compare against the speed of the potential installation of the intervention itself. Next slide, please. So that's where we've got to, and obviously as we come out of, well, hopefully we come out of lockdown, the next step is then to begin to look at how we might look at individual assets and do exactly what Sophie was saying there about how do we look at the individual assets and get under the skin and really make that strategic work apply in an individual asset case. So I think that's really the overview, just to give people a bit of a flavour of what we were up to.
Brilliant, thank you, Duncan.
Can I ask a question? Can I ask Sophie a question, because it was something she said earlier, and it's one of the things that the council asked me. I
knew you'd ask the question, go on.
Oh, you know, you can't help it. But you made this comment about when is a building really at the end of its life, and I think that's one of the things that's come out from the discussion with our client is, sometimes the client says the building's just had it, but equally, I know there's a question that's been asked by Tim Wickens. All too often we jump down let's knock the buildings down and start again. And I've had conversations with another client recently about where I've said, well, why don't we leave some of the buildings on the site? And there was a real interesting debate. And so where do we draw that line? How do we make that assessment?
I think that's a really kind of interesting discussion point, and as you say, it's kind of some really interesting points from Tim on the discussion there as well. It's not necessarily, I think, as I say, there's not like a universal rule that applies across the board, but what is useful to understand is, for example, maybe that building's operating is very kind of poorly performing because of certain characteristics associated with it, but that doesn't mean it necessarily has to be written off completely. And if we start to understand what the embodied carbon effect is, then what we can look at is, for example, is the ultimate kind of the frame associated with the building, for example, can that still be used? And that means that you've immediately reduced part of your embodied carbon by reusing an existing frame, but perhaps you kind of maybe dismantled kind of the exteriors or the facade panels or something like that. So it's understanding what resources you have available and how these can best be reused or optimized in order to kind of better benefit your overall strategy. So it might not be necessarily, you might be able to reuse some of the building, you might not want to kind of go down that route, or there might be kind of other concerns associated with it. But in terms of the embodied carbon, if we can first reduce that prior to kind of then selecting lower specified embodied materials, then that initial reduction is going to get you further overall. I don't know if that kind of helps in terms of what you're meaning, or...
Yeah, I think that's helpful. I think just as a further example, possibly we were asked just in the last week about we're discussing a potential retail unit conversation where the retail model is very much one of being driven for particular tenants, and we'd seen this option being developed whereby the potentially we were going to demolish the entire building and then rebuild it on an identical footprint, because with a slightly subtly different geometry to the roofscape. And we questioned it on a number of occasions, and it does sound like we're now beginning to have that a more positive conversation. But it really is about having those honest conversations with clients. Are you really sure? Equally, as structural engineers, we see some opportunities all the time where we use repurpose and support the repurposing of buildings where it's entirely possible to add extra floors on the top without knocking down the building that you've got. And so it's not all necessarily about you need more space. Well, maybe there's ways you can work with the buildings you've got to get more space.
And I think as well that kind of touches on another point as well, which is kind of designing for flexibility and adaptability. So if you can design or kind of modify the building in order to suit the immediate need, but if you're then going on to consider how future occupants or tenants might use that space, then you can start to incorporate that flexibility and kind of say, we'll do this for this measure, we'll do this as a kind of interim measure for this period of time, but if it's going to be used, then how do we allow that space to be bigger, smaller, or how do we allow the kind of service and strategy to be different kind of for different future tenants and so on as well.
I would certainly encourage Tim and the Northumberland and Newcastle Society in the question to get...
I'm trying to get in there with it, Duncan.
Absolutely. Well, no, he says, well, what can we do on a practical level? For example, I would encourage them to, and indeed the architects, the fellow creators in the room, to look at the AJ is running a retro first campaign to actually think about how can you reuse what we've got, and because often it's by the time it gets engineers with the best will in the world, we're brought on later, and it's those early concepts, those early inspiration that architects and maybe agents bring to the table of, well, you could do this. Those are the things that really capture the imagination of our clients. And actually, it's those initial thoughts, the concept of retro first, which many of the sort of architectural practices from across the UK and the globe have signed up to. That's the first step. It's setting that direction and maybe giving those opportunities and just putting that option on the table. Is a really a good thing to think about.
Yeah, absolutely. We had obviously a couple of questions through on the chat, which is mostly the same as what we've covered about what is a dead building and which is perhaps beyond remediation, which I think we've covered, and I've just published Tim's question there so everyone can see it in full. But again, I think you've answered that already. That is the end of the questions now. Oh, sorry, someone's just come through on the chat to say huge benefit to retro first in reducing waste and mitigating waste tourism, which is a big problem in Scotland. Thank you. Yeah. So yeah, that is the end of the questions now. If anyone's got any further questions that they want to add, please do get in touch with us. And I'm sure Sophie, Duncan or Gordon will be able to assist you there. As Sophie has mentioned, we'll be putting this session on YouTube, so you'll have access to the slides and can revisit them at any time. But as I said, if anyone's got any further questions, just get in touch with us. I'd just like to extend my thanks there to Sophie, fantastic presentation, and to Duncan and Gordon for your input too. And thank you to those who've joined us this morning. Thank you. Cheers. Bye, everyone.
Thanks, everyone.